Chesapeake Bay entrance, deviation, and compass error problems. The deviation and compass error problems are worked as a process of elimination. And what you're going to find is every one of the questions is going to say, I looked at this marker and I looked at this marker and they were in a bearing of so much, such and such per standard magnetic compass. So I want to find out if my deviation table is correct. So what I want to do is they're going to tell me what they see the bearing is as far as the PSC, and I need to go to the chart to find out what the true bearing is. So now I'm working on both ends of the formula. My TVMDC, I want to find out what the T is. So if we take the first question, it says we sight wolf trap light in line with New Point Comfort spit light, number 2, bearing 40 degrees per standard magnetic compass. Meaning we took our azimuth, we turned it, and we found the direction, and we found it according to our compass. Since we're on a course of 319 degrees per standard magnetic compass. Now what do we have to find? We have to find out our answer. Do we know that the compass error is 8 west? Should apply 3 easterly deviation? Know the deviation table is correct, or should suspect the compass is affected by local magnetic disturbance? How we answer that is we're going to have to come up with our formula, TVM DC, and they're saying that we see it at 40 degrees PSC. So I have my 40 degrees here. I need to find out what the actual true is. Now, we're going to go down and find York Spit Comfort Light, and I'm going to go ahead and open it up. And we're going to be working in this upper portion of the Chesapeake Bay chart, and I'm going to zoom in. This is kind of a hard light to find, and if you had your light list you'd be able to find it because they give you the latitude and longitude in it. But this is New Point Comfort, not to be confused with Old Point Comfort, which is on the southern part. This is New Point Comfort, and if you look, there's 2 lights out here. One is marked 4 and one is marked 2. And this is a guy that kind of hides because of this little mark on the chart. The number 2 is hidden, so a lot of people have trouble finding this light. But there it is right there, and it says it's flashing 2 seconds, 18 foot, 4 nominal range. This is our number 2. You see it's marked. It has a quotation mark and it's number 2. That's the buoy we want. Okay, so they're saying we see this buoy and wolf trap light in line with one another, PSC. So what I'm going to do is I'm going to go ahead and raise it up a little bit, and we're working in close proximity, so I want to find out what the true bearing is of number 2 and wolf trap light. I'm going to take my parallel rulers, I line them up, I walk them to my crosshair, I make a mark, 32 degrees. So when my boat's down here, our boat's around here, I look up here and I see this light in line with this light bearing 40 degrees. But I go to my chart now and I find out the true bearing is 32 degrees. Variation is 9 west. Now, what I'm going to do is I'm going to go into my book and I'm going to work C to T, compass to true. What's my deviation? Now, it says you're on a course of 319 degrees. I have to find out what the deviation is for 319 degrees. Pull out my deviation table. 319 degrees. 319 degrees is right between 300 and 330. I'm going to go ahead and call it 1 east. And the reason why is because it's so close. I'm going to go ahead and call it 1 east. So I'm going to go ahead and take now our deviation for 319 degrees is 1 east. I'm going up, so I add east. So magnetic heading is 40. 1. I forgot to add it. 41. 40 plus 1 is 41. Now I have 9. Remember now, I have 9 west. So what I'm going to do is, I'm going to subtract 9 from 41. And look, I get 32. So what does that tell me? That tells me my deviation table is correct. If 41 minus 9 was something totally different than this, then I know that my deviation table is wrong. Now let's go back and look at the answers. You see the first one, that says, know that the compass arrow is 8 west. Here's how you find this. My compass arrow was 9 west, variation, 1 east, deviation. Now, I have unlike signs, so this is almost like this is a negative and a positive number. So what this is going to be is, if these were both the same, if both of these were east or both of these were west, I would add the 2. But because they're different, I'm going to subtract the smaller from the larger number and take the sign of the largest number. So that it is 8 degrees arrow. So I'm going to go over there and go, okay, that's a good one. I'm going to go ahead and make a mark there. Look at the next one. Should apply 3 degrees easterly deviation to the bearing. If I'd have added 3 east here, this would have been 43. And then subtract 9 from it, I wouldn't have got 32. I would have gotten 44. No, 34. So that's not going to eat out. So no, that's wrong. No, the deviation table is incorrect. No, the deviation table is correct, because it's got me 32. That's a known fact. This is not a guesstimation. You know that light, those 2 lights are bearing 32 degrees on your chart. There's no ands, ifs, or buts. So in order for these numbers to equal out to 32, 1 east was right. So the deviation table was correct. It wasn't incorrect. And you should suspect the compass may be affected by local magnetic disturbance. This is only if the chart actually has it. If you actually take the chart and you look down at Cape Henry and just look down a little bit farther, and you're going to see local magnetic disturbance on the chart there. That area does have local magnetic disturbance, but you'll never run into that unless you're working into that area. So that's where you want to work. You want to be able to line up the marks. So every one of these, what you want to do is you write your TVMDC, find the deviation of your heading. They're going to give you the compass heading. Find that deviation, get your magnetic. Go to the chart, and it's going to say, on the next one it says thimble shoal light and old point comfort light, and you're going to get them in line. Try to find out what the true is and write down the true. Variation in this area is 9 west. If you take this magnetic heading and subtract 9 from it and don't even come close to the T, then you know that the deviation is wrong. This has to work out. If it doesn't work out, then you're going to go back and suspect your deviation is wrong. Let's just, if I take one